All right, good evening, everyone. Tonight, our little brief training is going to be on the persistence method. This is basically the easiest way of forecasting, especially in an area where the air mass doesn't change. Like we're in Southern California, and we went from 50 degrees and raining to I think it was 94 today. So more than likely, it's going to be hot for a majority of the year, and looking to start cooling down probably November time frame. But like it says here, the persistence method works well when weather patterns change very little and features on the weather maps move very slowly. It also works in places like Southern California, where we are, where summertime weather conditions vary little from day to day. So, and it's saying basically down here that numerical weather prediction lose relevance about after 10 days. So this is basically the easiest way of doing it. Now, we're going to look at the model. The model, to me, it makes no sense. I'm not a math guy. You start throwing letters in there and I don't know, it's all Greek to me. So as it says, persistence model is often used as a reference for determining the skill factor. It is useful to know if forecast model provides better results than any trivial reference model, which is the persistence model 24. So right here, it's going down. Its accuracy decreases with the time horizon and generally not adequate for more than 1 hour. So they show the improved model, persistence model, GT, like clear sky. Persistence methods implies that future values of the time series are calculated on the assumption that conditions remain unchanged between current time t and future time t plus th. For a stationary time series, one whose mean and variance do not change over time, a straightforward implementation of persistence model is simply, that's not simple. But normally what I do, I'll go into ads, go to ads metars. You guys pretty much all know how to get there. So right here, request metar data for KRIV, our station. We're going to go out 36 hours. I'm going to grab metar data. We don't need the TAF since we're going to kind of write our own. So looking back, the start of the period, winds mostly out of 300, 6, 8 knots. Okay, so not seeing anything jumping. And as long as they're not seeing any tightening of the gradient or anything else, like it says, moving slowly, tomorrow we'll see winds out of the northwest between, I'd say, 6 and 8 knots. So temperature here, let's see, we'll get the min to me, let's see, there's an 11. So say minimum temp will be 11. The max temp will be 34, 35. And this is just kind of a swag, but if you have no other data, this is basically the best way to do it. And like I said, it's summertime. Everything's moving slowly. So today is going to look much like yesterday, and then tomorrow much like today. So that will basically conclude this lesson. Hopefully it's useful. You guys maybe have different ways of doing it, but like I said, if there's no other info, your websites are down for whatever reason, and this is just, I'll give you a basic, at least for a 24 to 30 hour period. You could give the air crew or whomever a heads up, say, hey, more than likely it's gonna be like today. So have a good night. Let me know what you guys think, and like we did last time, let's start a conversation in the GroupMe.